B will be the distance between them. So the distance is equal to the square root of, what is x sub 2? Minus x sub 1. 20 squared plus y sub 2 minus 4, 20 squared. Simplify. What's 3 plus 2? Squared plus negative 6 minus 10, or minus 4 squared. Can you ever get a negative underneath here? No. When you square something, it becomes so it's going to be x sub 2 minus x sub 1. So you get the square root of 125. Is there a perfect square divides evenly into that? What is it? 25, so I get 5 roots of 5. Now, some of you really like to use the formula. I don't. I like to do this. I like to think about it as a triangle. Just think about, folks, what's the distance between negative 2 and 3? 5. What's the distance between 4 and negative 6? 10. So then I don't even write down the formula. I got 5 squared plus 10 squared is that. And I use Pythagorean theorem. And you might say, well, why? What on the ACT, you got 60 minutes for 60 problems. So you decide if you want to write down the formula and work it out. Can you get done in a minute? Well, yeah, probably. But there's other problems you can't get done in a minute. So you got to pick and choose where you're going to save time. So when I look at that, I just go right away to the Pythagorean theorem. Every once in a while, you come up with a Pythagorean triple. Anybody remember your Pythagorean triples from geometry? No? Come on. Yes, they did. Don't tell me they didn't. I've taught geometry. I see what they're teaching all the time. You tell me that you never saw 3, 4, 5 work out to be a Pythagorean triple. Yeah, you did. You also saw this one, 5, 12, 13. You also saw 6, 8, and 10 because the multiple of any of these will also work out. So therefore, you'll also have multiply by 5, you get 15, 20, and 25. Maybe remember 7, 24, and 25. Or remember 8, 15, and 17. The point is this. The more of those you remember, the quicker you're going to be on those tests. But I know some of you remember at least 2 of them. And the better you can remember Pythagorean triples, the better off you're going to be. So you do end up with a Pythagorean triple in that one. But I'm just trying to help you save time. It's your ACT score, so we want to do well. C. It says find the midpoint. Midpoint, middle is just the average. So I just find the average of them. What's the average of negative 2 and 3? Well, we add it and divide by 2. So what's negative 2 plus 3? 1 divided by 2 is a half. Average of 4 and negative 6. 4 plus negative 6 is divided by 2. So the coordinate 1, half, and negative 1. And if you look at my drawing, it would appear that about 1 half negative 1 would be about the midpoint. So I want you to understand the formulas in the way that they were first thought about, the concept behind it. The average and the Pythagorean theorem. That's what it is. We just have to tie the x1s and the x2s, the y1s and y2s, because of in order to write it in a nice way. You do B on your own. Go. You can check your answer when you get done, but I believe you should have 13 for the distance and negative 1 half 5 for the midpoint. Yes? Look at the difference between 2 and negative 3. Distance between 2 and negative 3 is 5. Distance between negative 1 and 11? 12. 5 squared is 25. 12 squared is 144. Adds to 169. Square root of 169 is 13. And midpoint is just the average. So you're going to practice today using the midpoint and distance formula. You'll be excellent at it. All right, example 2. Draw a triangle formed by that. direction state, draw the triangle. What kind of triangle is it? And what is its area? I'm not talking about angles here, so right or acute or obtuse. I'm talking about sides. What three different kinds of triangles do we talk about? Very good. Scalene, isosceles, so equilaterals, all the sides are the same. Isosceles, 2, and scalene, none. So you tell me which one of these can I eliminate right away just by looking at it. It's obvious that this side right here is the longest, right? That's obvious. So we need to see if it could be isosceles. So I want to look at the distance between the two sides. Well, this one's out of the mix, but what's the length right here? 5. You just count it, right? So from -3 to +2, we've got 5. So I want to see what length this is. So you can use the Pythagorean theorem or distance formula. So this coordinate here is 5, 6. And this coordinate here is 2, 2. We got the square root of 5 minus 2 squared plus 6 minus 2 squared. It's 5 minus 2 squared. 9. 6 minus 2 squared. 16. So we get square root 25, which is 5. So it is an isosceles triangle. I'm also asked to find the area. How do you compute the area? Yep. Okay. We'll look at that in a second here, but first, what is the formula for area? What's the length of the base? 5. Now let's just use some coordinate geometry here to figure out what the height is. Anybody look at this and determine the height? Would you agree that this is the height from there to there? Pretty easy when you got coordinate geometry, isn't it? You're going from a height of 2 to a height of 6, which is 4. So 10 is your area. And if you would have done the Pythagorean theorem when you did your distance, you would have seen that that was 3, that was 4, so that's 5, and then you would have seen your height right away. Right? Again, I'm just trying to help you, give you some things that on the ACT will make it run fast for you. Okay? No. All right. Move to, no, not that one. Right there. Flip to that one. Who's got stapler? All right, moving around. Okay, when you are done with college algebra and college trigonometry, there should be 2 skills that you for sure have. Number 1, you should be able to solve any equation that you see. Number 2, you should be able to graph any equation that you see. So solve and graph. Now, today we want to focus on the graphing aspect. Anybody like opposed to graphing where it's like, I don't really care for that. Every time they do that in class, it's kind of like, ugh. Nobody? 1, 2? A lot of times when you see graphing, people are like, I don't like to do that. I think that when you can view the graphs, math becomes easier and it becomes more connected. I understand why polynomials behave the way they do, when I can see visually what's going on. Without a doubt, when you get into calculus, you have to be able to view the graphs. If you don't understand what the graph is doing, you won't get calculus. A lot of people like to center their world around algebra. Algebra is just such a small little snippet of mathematics. And once we can understand graphically what's happening, the world opens up. So let's talk about intercepts. Intercepts, if I have a graph like that, okay, first of all, is that graph a function? Why? Doesn't pass the vertical line test. Functions say that in order to be a function, you have to pass the vertical line test. You can't cross in more than one spot. This one would. However, we can still graph it. And as we do, sometimes finding intercepts is the best way to graph. That point right there, is that the x-intercept or y-intercept? It's the x-intercept. And if you think about it, it has some x value. We don't know what the x value is, but we do know the y value. What's the y value? 0. And with the y-intercept, obviously it has some y value. We don't know that, but we do know the x value. What's the x value there? 0. And same thing down here. That tells us very plainly how to find x and y intercepts. To find the x-intercept, you set y equal to 0 and solve for x. And to find the y-intercept, you set x equal to 0 and solve for y. And finally, if you need even more points in order to graph it, you can always make a table. And you remember that you can make an XY table. Say you plug in 1 for x, you can solve for y, or plug in 4 for y, and you can solve for x, whatever it would be. Those are strategies right now for graphing. So we're going to use 4 examples, and then you're going to be able to work on your assignment in about 15 minutes. It says generate the graphs by finding the x and y intercepts and finding one additional table value. First of all, can you look at number 1 and determine what kind of graph it is? What does it look like? It's linear because they're all to the first degree, so therefore it's a line. Now, when you see a line, you often think, oh, need to put in slope-intercept form. No, you can sketch this a lot quicker than putting it in slope-intercept form. Just find the x-intercepts and the y-intercepts. The x-intercept will happen when what is equal to 0? When y is equal to 0. If you plug in 0 for y, what's the new equation read? X is 8, right? Already got 1. And if you plug in 0 for x, that'll give you the y-intercept. Plug in 0 for x, what's the new equation then? Negative 4y is 8. Solve by dividing both sides by negative 4. And we get y is equal to negative 2. Boom. Done. Easy peasy. Yup. So mark it off. This travels through negative 2 on the y-axis, positive 8 on the x-axis. My graph. Now you knew that that was a shape because they're both to the first degree. You know that makes a line. However, suppose we needed one more point. As the directions say, give us another point. Now you can plug in whatever you want. Give me a number you want to plug in for x or y. 2. 2 for x or 2 for y? Okay, 2 for x. So if x is 2, then you have 2 minus 4y is equal to 8. Or negative 4y is equal to 6. So y would be equal to negative 3 halves. Does that look like it's a point that fits on our line? Over 2 and down 1.5? Yeah, it looks like it fits. Does that make sense? See why that's efficient? Okay, then let's try the next one. X-intercept. Plug in 0 for what? Y. So 0 equals x squared minus 2x minus 8. How do you solve something like that? Factor. So 0 equals x minus 4 and x plus 2. So what are the solutions? So there's 2 intercepts. Okay, let's go to the y. Plug in 0 for x. What do you get? Isn't that nice? You got negative 8. You got a positive 4. You got a negative 2. Looks like the graph maybe does something like that. I want to try to find another point. Is it easier to plug in a value for x or a value for y for this problem? X, yeah. What do you want x to be? 1. Plug in 1, we get 1 squared is 1, minus 2 is negative 1, minus 8 is negative 9. Does that seem to fit on our graph? Yeah, I maybe didn't draw it as far down as I should have. Okay, there, maybe that's better. That's it. Number 3, what does it look like when you find the x-intercept? What's the equation look like? X equals 9. Just plug in 0 for y, the y's go away. The y-intercepts, plug in 0 for 0 equals 9 minus y squared. How do you solve that? Three minus y, 3 plus y. It does factor, right? So my solutions are plus or minus 3. So I'll plot that. X value of 9, y value of positive 3, and negative 3. Huh, what do you think this looks like? Similar to the last one. Parabola just sideways. Instead of x being squared, the y is squared. Let's make up another value. There's a right answer here, folks. Is it easier to plug in a value for x, or is it easier to plug in a value for y? For y, what value would you like to plug in for y? 1, that'll be fine. Okay, if we plug in 1, we get x equals 9 minus 1 squared, which is 8. If you would have plugged in negative 1, what would you have got? 8, right? Look at that, I found 2 more values. So if you go over 8 and up 1, or over 8 and down 1, looks like those fit on the graph. Looks like I did a good job of graphing it. One more and we'll stop for the day. X-intercept, plug in 0 for what? for y. And we get x squared is equal to 16. So therefore, x is s minus 4. For y, plug in 0 for x, and you get, what's my new equation? Y is plus or minus 2. Let's see here. So I got x is positive 4 and negative 4, and y is positive 2 and negative 2. What kind of shape is that, do you think? Actually, it's like an oval. It's called an ellipse. It's called an ellipse. And we'll learn a lot more about graphing those second semester, but that's the general. Let's come up with another point. Does it matter whether you plug in something for x or y? I think it's easier probably something for y, but it probably doesn't matter. I'm going to plug in 1 for y. If I do that, I get x squared plus what? 4 is equal to 16. So x squared equals 12. Square root both sides. What's the square root of 12? 2 root 3. But because you're solving for a variable squared, you would also have, so 1 can be paired with 2 roots of 3, or 1 can be paired with negative 2 roots of 3. 2 roots of 3 is about 3.4. So if you go to plot this, go over, I'm sorry, over 3.4 and up 1, or over the other way and up 1. And you can see it looks like it's going to fit on the circle or on the ellipse there, the oval there. It works out. Yeah, so for your assignment, what I'd like you to do is this. Now, be careful. 3 through 6 is just the lines and the distance and the midpoint stuff. 27 through 29 are ones like the triangle problem that we had. And then 43 through 54 and 56, the directions, kind of just disregard the directions. What I'd like you to do is just find the X and Y-intercepts. Quantitative value, like we did. It asks you for symmetry. Don't worry about testing for symmetry. You don't know how to do that yet. But do make sure you sketch a graph. If you got to. Make sure you get a picture of what it looks like. And then on Monday, we'll learn how to test for symmetry and do circles. If we keep going to page of graph, there's set field tests on Friday. It means I'll get you a study guide. We don't have a whole lot more content left. We'll be good to go. So you have the rest of the hour to work, which should be about 15 minutes.